In Chapter 2.3, we're going to be discussing Venn diagrams and set operations. This is Part 2. So in Part 2, you will learn how to determine the complement of a set, how to find the intersection of two sets, how to find the union of two sets, how to subtract two sets, how to find the Cartesian product of two sets. The complement of set A is symbolized A prime. This is the set of all elements in the universal set that are not in set A. We say the complement of A is not A. Given the universal set 1 through 8 and set A is equal to 1, 3, and 4, find A and illustrate the relationship among set U, A, and A prime in a Venn diagram. So in our solution, we go back and review that our universal set is the counting numbers 1 through 8, and that set A is 1, 2, 3. So we draw a circle, if you will see the Venn diagram, and we put in 1, 3, and 4 because that's in set A. The rest of the numbers that are in the universal set are put in the box 2, 5, 6, 7, and 8. A prime, therefore, is those numbers that are not in set A, which is 2, 5, 6, 7, and 8. The intersection of sets A and B, symbolized by A with the horseshoe shaped upside down, B, is the set containing all the elements that are common to both set A and set B. In our representation of the Venn diagram, you will notice that region 2 represents the intersection. It is overlapping both A and B. So in our example, we have a universal set of the numbers, the counting numbers 1 through 10. We have set A being 1, 2, 3, and 8. Set B is 1, 3, 6, 7, and 8. And C is the empty set. So our first question is find the intersection of A and B. Then we're going to find the intersection of A and C. Then we're going to find the intersection of A prime B. And then we're going to find the intersection of A, B prime. So in our first example, we're finding the intersection between A and B. That is, what are the common numbers that are in both A and B? So in this particular example, we see that the number 1 is common to both A and B. 3 is a common number, and also 8 is a common number. So the elements common to both sets A and B are 1, 3, and 8. So therefore, that is our intersection. Now we'll look at the intersection of A and C. Here, we have A is 1, 2, 3, and 8, and C is the empty set. There are no common elements, there's no elements common to both A and C except the empty set. Therefore, the empty set is the answer. In C, we have A prime B, and first we must determine A prime. So A prime is not A. Any number that's not in A is in A prime. So in A prime we have the numbers 4, 5, 6, 7, 9, and 10. And so now the intersection of A prime B we can see is those numbers that are in common. In this case, we have a 6 and we have a 7. So the intersection is denoted in roster form 6, 7. In our last question, we had A intersection B prime. Well, we knew what the intersection of A and B are. We first determined that in part A, and we found 1, 3, and 8. Now we're looking for not the intersection of A and B, so all the numbers that are not of that set, right, is going to be 2, 4, 5, 6, 7, 9, and 10. So we've talked about the intersection. Now we're going to talk about the union. The union of the set A and B, symbolized by A with the upside horseshoe, B is the set containing all the elements that are the members of the set A or of set B, or of both sets. So, in this particular case, the union represents all three areas, 1, 2, and 3, of the Venn diagram of the circles. So now we're given, again, the same universal set, 1 through 10. A is different. It's 1, 2, 4, and 6. B is 1, 3, 6, and 7, and 9. And C is the empty set. It says find the union of A union B. Then we're going to find A union C. Then we're going to find A prime union B. And then finally we're going to look at A union B prime. So in our first example, we're going to look at the union of A union B, and we just have all of the numbers that are listed, and if it's listed twice, we only list it once. So in this case, we have 1, 2, 3, 4, 6, 7, and 9 that are both elements in A or in B. So in the case we have A union C, we have 1, 2, 3, 4 union with the empty set, and of course with the empty set that's just the same as the same numbers that are contained in A. So in this particular example, A union C in this case is just A. So now we're looking at A prime union B. Again, the objective is first determine A prime. A prime in this case is 3, 5, 7, 8, 9, and 10. And B, of course, is then 1, 3, 6, and 7. And so the union is all elements that are in A or in B. And so we end up with 1, 3, 5, 6, 7, 8, 9, and 10. In our last example of unions, we have A union B prime. First we determine the union of A and B, which we have done in the past, and we found it to be 1, 2, 3, 4, 6, 7, and 9. Now we want to take the complement of that, which is those elements that are not in 1, 2, 3, 4, 6, 7, and 9. And it's the rest of the elements in the universal set, which is 5, 8, and 10. So typically we have the words and or. And is generally interpreted to mean intersection. So A intersection B is equal to X such that X belongs to set A and X belongs to set B. Or is generally interpreted to mean union, where A union B is equal to X such that X belongs to A or X belongs to B. Notice in the or case, it could be in A, or it could be in B, or it could be in both. Whereas in the intersection, the elements have to be both in A and in B. So now we're going to find the relationship between n of A union B, n of A, n of B, n of A intersection B. Recall from our previous section that we looked at what's called the cardinality of a set. The cardinality of the set determines the number of elements in a set. So to find the number of elements in the union of two sets, A and B, we add the number of elements in set A and in set B, and then subtract the number of elements common to both sets. That is, for any finite set A and B, the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. So in our example, the results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? Well, our solution is set A is the visitors who speak Spanish, set B is the visitors who speak French, and we need to determine the union of A union B. So the number of elements in A union B is equal to the number of elements of A plus the number of elements in B minus the intersection, the number of elements of the intersection of A and B. In this case, we know that we had 25 that spoke Spanish plus 14 that spoke French, but there were 4 of them who spoke both Spanish and French. That total is equal to 35. The difference of two sets A and B, symbolized A minus B, is the set of elements that belong to set A, but not to set B. So in region 1 represents the difference of the two sets. Using set builder notation, the difference between two sets A and B is indicated by A minus B equals X such that X belongs to A or X does not belong to B. So here we have the universal set A, B, C, D, E, F, G, H, I, J, K. Set A is the set A, B, D, E, F, G, H. B is A, B, D, H, I. And C is B, E, G. It says find the following: A minus B, A minus C, A prime minus B. So to find A minus B is the set of elements that are in set A but not in set B. So we look and we see, oh, well, certainly B is in both A and B. D is in both B and D. So those cancel out when we subtract. And then H is in both those two. And so we're left with in A, E, F, and G. So that is how we subtract the elements in A minus B. Okay. Again, A minus C is the set of elements that are in A but not in C. So we go through and we say, oh, well, B is there, E is there, and G is there. So we're left with D, F, and H in A. Then we want to find A prime minus B is the set of elements that are in set A prime but not in set B. So the first step is to find A prime. In this case it's A, C, I, J, and K. Now we use that information to eliminate those elements that are in B. So we see that we have an A, we have a I, and so we're left with C, J, and K. The Cartesian product is usually not used very often. Is the set of A and the set of B symbolized A times B and reads A cross B is the set of all possible ordered pairs of the form A comma B, where A is an element of A and B is an element of B. So we consider ordered pairs when we're looking at two elements or two sets in the Cartesian product. Select the first element of set A and from an ordered pair with each element of set B. Then select the second element of set A and the form of ordered pair with each element of set B. And continue this manner until you've used each element in set A. So for example, we have A is equal to orange, banana, and apple, and B is 1 and 2. Determine the following: A cross B and B cross A. So for A cross B, we have orange 1, orange 2, banana 1, banana 2, apple 1, apple 2. See the ordered pair. Now we'll do B cross A. We have 1 orange, 1 banana, 1 apple, 2 orange, 2 banana, 2 apple. Notice the difference in the way we've distinguished between the two sets. This concludes our chapter 2.3. We will be going into chapter 2.4 soon.